With our first example, we have a population which satisfies this logistical differential equation right there. We see that dp dt is equal to p times the quantity 2 minus p over 5,000. We're also given an initial population, and we're asked what's the limit as t approaches infinity of the population. Right? So we know from the introduction and the idea behind a logistical differential equation that the limit is going to be equal to the maximum value of the population. Right? Now, the maximum value of population is located at the first part of the group inside the logistical differential equation. Okay? But now looking at this, the maximum population is definitely not 2. So what's going on here? Well, the maximum population is m as long as the second term is just p. And right now we don't have that. We have p divided by 5,000. So the idea, this little type of trick that they may put in is to understand what is this the equivalent of? All right, and so what they're looking for you to do is say, okay, well we actually just want a p term after the subtraction, all right, which means we'd have to get the 5,000 out of there, right? We'd have to multiply by that 5,000. That's the idea. So when we do the same thing to the 2, we end up with that 10,000, all right, and we still have the p out front. Okay, so now we can see that the m matches up with the 10,000, so we would select option E, okay, for that first example. Again, the idea is just that the limit is the value of m. They may not directly give you m. They may ask you to do a little bit of calculation to figure that out. For example number 2, they give you the graph of a population, logistical growth model, for a population rather, and they say which one of those 5 equations could represent this graph right here, or could model it. Right? So again, here is our logistical growth population formula. Right? And if we look at the 5 answers, they all have p squareds and p's. So as you might imagine, we want to distribute this kp term to both parts. Right? And when we do so, we can see that dp dt is equal to k times m times p minus kp squared. Right? So notice how the quadratic term happens to be negative. All right? We have that negative coefficient right there. So we want a function, or rather a diffie in which the p squared term is negative, which I believe eliminates c, d, and e. So the question is it option A or is it option B? Right? Well, what do you think it should be? There's a little bit of information that was given to us, which I'm covering, to get out of the way, which can help us get our answer. Right? What's the maximum population? It's 200. Now, the maximum population is the difference between the coefficients right now. So we need a coefficient, the first coefficient needs to be 200 times the second coefficient. And I believe that's going to leave us with option number A as far as our answer.